Hello, my name is Steven, and I'm going to be making up the pre-algebra video. How about we get right into it? First thing we are going to talk about will be basic definitions. I will be defining a few sets. The first set we're going to talk about is the set of natural numbers, which is also called the counting numbers. Well, like I've been saying, it's a set. And the elements of a set, in this case, the numbers of the set, are listed between these curly brackets. The natural numbers, the counting numbers. Well, how do you count? When you go to count, what do you start with? The answer is 1, and then 2, and 3, and 4, and so on. The 3 dots mean and so on. So that's the list of the counting numbers. 1, 2, 3, 4, 5, 6, etc. So 208 is a natural number. How can that possibly be? And after all, you might say, well, I don't see 208. I only see 1, 2, 3, 4. Well, you have to start realizing that there's many numbers in those 3 dots, and it's not just 5, 6, and 7. The set are natural numbers. They have 1 and 2 and 3. I mean, think about how you're counting something. You have a stack of paper, and you're being asked to count the number of pages. And maybe I'm watching you, and I hear you go 1, 2, 3, 4, 5, and then I leave. And you go 6, and 7, and 8, and 9, and 10, and I come back a little while later, and there you are, 205, 206, 207, 208, 209, and so on. Eventually, you get to 208 when you are counting. Eventually, you get up to 208. 208 is a counting number. You know, in my little story, maybe it was only 78 pages, so when I come back, I will not have heard you say, nor would you have ever said 208. But let's play the game differently. I just ask you the count. Eventually, you'll hit 208. 1, 2, 3, 4, 5. Eventually, you'll hit 208. You know why? Because 208 is a counting number. So even though in the list above you don't actually see the number 208, you better believe it's a counting number. The next set that we're going to talk about or list are the whole numbers. Well, the whole numbers contain each and every natural number. That is, the whole numbers contain 1 and 2 and 3 and 4 and 5, etc. And it also includes 0. 0 is the only difference between the whole numbers and natural numbers. Every other whole number is a natural number. There they all go. But the whole numbers also contain 0. When you start to count, you don't start with 0. Now, you have the integers. The integers, they contain all the whole numbers. They contain all of these numbers here. They contain 0. It contains 0 and 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 forever. It also contains -1 and -2 and -3 forever. To the left. Contains 0. It contains the positive counting numbers and the negative counting numbers. The next set is a little bit unusual. The rational numbers. It's unusual because you can't really list the rational numbers. Like I listed the integers, or at least I wrote it down in a way where you can understand it pretty easily. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. -1, -2, -3, -4, -5, -6. There's actually some kind of an ordering. The rational numbers can be written in a special form. Can be written in the form A over B. That's a division. But now I have to tell you where A and B can be. Are A and B just integers? Are they whole numbers or natural numbers? Or maybe a new type of number? Well, here it is, where A and B are integers. And the bottom is not 0. This is read as A divided by B. A over B. A divided by B. So we are dividing by B. And I'm saying B can't be 0. That is, you cannot divide by 0. Is that just a rule? Oh, you can't divide by 0 because somebody said so? And the answer is no. You really, really can't divide by 0. It just doesn't work. If you actually try to divide by 0, you will have trouble. And here's two arguments. 8 over 2 is 4. And the check would be 2 times 4, whether or not 2 times 4 equals 8. And of course it does. Therefore, 8 divided by 2 is 4. If somebody asks you, what's 10 divided by 5? And say you actually didn't know, you don't have to worry. You might still be able to get the answer to what is 10 divided by 5. And how do you do that? Just ask yourself, 5 times what equals 10? The answer is 2. The top one, 8 divided by 2 is well defined. It's defined to be 4. 10 divided by 5 is very well defined. It's defined to be 2. Now, what about 7 divided by 0? Well, you may say, well, I don't know what 7 divided by 0 is. Just like we were saying, you don't know what 10 divided by 2 is. Well, how do you figure out what 7 divided by 0 is? You ask yourself, 0 times what equals 7? The thing is, no matter what number you put here, say 0. 0 times 0 is 0, so it's not 7. What if you put -7? Well, let's not go there. What if you put 7? 0 times 7 is 0, which is not 7. If you put 8 over 9, 0 times 8 over 9 is 0, which is not 7. If you put 13, 0 times 13 is 0. It's not 7. And instead of 7, if I had 17, I would be saying the same thing. 0 times that list of numbers will always be 0. It's never 17. That's why this fraction, 17 over 0, is said to be undefined. It can't divide by 0. I tried. I really did. Didn't work. Let's try to actually do long division. Maybe you can do long division and 7 over 0 will give you an obvious answer. Now, let's just review one step with long division. Say 2 into 7. You want to put the largest number up there, so when you multiply 2 by that number, you don't go over 7. And 3 is the answer, because if I put a 4 here, 2 times 4 is more than 7. So it's not 4 that goes there, but rather the number before, 3. 2 times 3 is 6. And the remainder is 1. 2 goes into 7, 3 times with a little left over, 1 left over. Well, now remember that this division, 2 into 7, is 7 divided by 2. Well, if you want 7 divided by 0, that means you do 0 into 7, just like we did 2 into 7. The 7 went under the bar, the denominator, the 2 went in front of the bar. The denominator goes in front of the bar. All right, so what's the largest number I can multiply 0 by and not go over 7? Well, a lot of you might say 0. 0 times 0 is less than 7, it's 0. Some of you might say 1. 0 times 1 is 0. That's less than 7. Me, I like big numbers. 2,318. 0 times that number is 0. 0 times 2,318 is 0. That's less than 7. Some of you might say, you know what? How about 2,318,724? That's 0. That's less than 7. You can just keep adding. You can make this number as big as you want. You can just get all carried away. And you know what? No matter how big that number is on top, 0 times that number is not more than 7. You can't divide by 0, folks. You can't. That is why I said that the rational number can't have 0 in the bottom. Because if you have 0 in the bottom, it's very simple. You're not a number. Period. You're not a number. If you're not well defined, you're not a number. So that's rational numbers. Now, some numbers cannot be written as the division of 2 integers. So it's not rational. A number that is not rational, that is not a rational number, is called irrational. A number that is not rational, that is a number that cannot be written as a division of 2 integers, is called irrational. For the record, pi is irrational. Some of you may say, well, that's not true, because pi is equal to 22 over 7. Well, I'll agree that 22 over 7 is rational, but I won't agree with it equaling pi. Okay, I will not agree with that for a second. I will agree that pi is approximately 22 over 7, but it isn't. I'm not going to get into why, but the square root of 2 is irrational. No 2 integers, when you divide them, will equal 2. You can find 2 integers when you divide them, no 2 integers when you divide them, I think I said give you 2. No 2 integers when you divide them will give you the square root of 2. But you can come close. You can find 2 integers, so when you divide them, you get really, really close to square root of 2. But you'll never get exactly that. You can stand on your head, but you won't get 2 integers to divide and give you the square root of 2. You could come as close as you want, but you'll never get the square root of 2. Okay. So there are some numbers. This is a bit advanced irrational numbers. But if a number is not rational, then it's irrational. Numbers you don't know the square root of, like the square root of 2, the square root of 3. The square root of 4 you know, it's 2. And if you don't know square roots yet, it's coming up later on. These numbers are all irrational. The square root of 9 we know, it's 3. So the numbers you don't know the square root of, they are irrational. The next set we're going to talk about is the set of digits. What's the smallest set of numbers you need to write any number. Like to write 734, you need a 7, a 3, and a 4. So the digits must contain 7, 3, and 4. The digits are 0, and 1, and 2, and 3, 4, 5, 6, 7, 8, and 9. 7, 8, and 9. Those are the digits. Any number that you want to write, 1004. Well, you need a 1, you need some zeros, and you need a 4. And we have them in those digits. And if you removed any one of these numbers from this list of digits, you'll be in trouble. Like if you remove the 8, if you say no 8 in the digits, well, good luck in writing 728 or 781 or 801. You couldn't write these numbers. That is, you must have 8 as a digit. For example, we don't need to include 10 as a digit. Why is that? Because to write 10, you need a 1 and a 0. That is, to write 3104. You don't need a 10. You can to write 3104. You can get excuse me. You can get away with just having a 1 and a 0. Well, you may say, well, you know what? I'm going to remove the 1 and the 0. I'm going to put a 10. Well, that gives you trouble, because then you can't write 308, because you need a 0. So it turns out that the digits must be the whole numbers from 0 to 9. Remember, the whole numbers start at 0. But it's not each and every whole number. It stops at 9. So 0, 1, 2, up to 9. Those are the digits. You can just go and remember digits are whole numbers from 0 to 9. But in addition, I gave you the explanation as to why. The digits are the smallest set of numbers that you can use to write any number. To write any number. Now, the next thing we're going to talk about, well, I'm going to ask some true-false questions. Remember, the natural numbers, they're the counting numbers, 1, 2, 3, forever. The whole numbers have all the counting numbers, 1, 2, 3, forever. They also have 0. And the integers, they have 0 and -1 and -2 forever, as well as 1, 2, 3 forever on the other side. And the rational numbers, they can be written as A over B, where A and B are integers and B is not 0. So now some true or false questions. 9 is a whole number. The answer is true, because eventually you'll get to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Eventually you'll get to 9 when you go to the whole numbers. -8 is an integer. The answer is yes, this is true. 0, -1, -2, -3, -4, -5, -6, -7. Eventually, you'll get to -8. How about every whole number is an integer? Well, I go to the whole numbers and I go to the integers and I see the whole numbers right in there. Every whole number is an integer. 0 is an integer, 1 is an integer, 2 is an integer. Every whole number is in the list of integers. How about every natural number is a whole number? So I'm asking, if you go to their natural numbers, if you go to the whole numbers, will you see the natural numbers? Is every natural number a whole number? And yes, I just underlined every natural number. And you won't believe it, but I found it in the wholes. I found it in the list of whole numbers. So yes, every natural number is a whole number. This is true, as well as the one before it was true. Every natural number is a whole number. What if I interchange these? What if I write every whole number is a natural number? Well, 0 is a whole number. 0 is a whole number. But you know what? It's not a natural number. I don't see it in this list. I don't see it here. 0 is a whole number, but it's not a natural number. Say every whole number is a natural number. That's not true. Not every whole number. 7's a whole number, and it's a natural number. 2's a whole number, and it's a natural number. 0's a whole number, but it is not a natural number. So no, not every whole number is a natural number. I can ask, some whole numbers are natural numbers. That's absolutely true. Some. What does some mean? At least one. Some people in your class got an A on the last exam. That means one or more. Some whole numbers are natural. Yeah. 2's a whole number, and yes, it's natural. That's enough for me to say yes to that statement. You have to know what some means. How about every whole number is an integer? Well, I go to the, well, we already did that one right here. I'm sorry. How about every natural number is an integer? Well, I go to the integers, and I look to see if every natural number is there. And yeah, there it is. Those are the natural numbers. So every natural number is an integer. Now, here's an interesting one. How about every integer is a rational number? Every integer is a rational number. Is that statement true or false? And I assure you it's one or the other. Either it's true or it's false. Every natural number is a rational number. Now remember, it's very, very simple to be a rational number. How do you come to be a rational number? If you can be written as a division of two integers. Now, I was very, very careful in how I worded that. I said can be written as. That's exactly how I defined a rational number. You don't have to be in that form. You just have to be able to be written in that form. Now remember, the integers have 0 and 1 and 2 and 3, etc. And -1 and -2 and -3, etc. And those are the integers. They're not in the form of a fraction or division of two integers, but you know what? 1 over 1 is 1, and 2 is the same as 2 over 1, and 3 is the same as 3 over 1, and 4 is the same as 4 over 1. 0 is the same as 0 over 1. Let's check that one. 1 times what equals 0? 0. Only 0. 1 times 1 is not 0. 1 times -8 is not 0. 1 times 0 is 0. So 0 over 0 is still 0. -1 is -1 over 1. Negative 2, you can divide by 1 and still get negative 2. Negative 3 is the same as negative 3 over 1. All of these numbers all the numbers I have now are the division of two integers. And the bottom is not 0, they're all 1. But nonetheless, so now these are rational numbers. But nonetheless, it's 3 and 2 and 1 and 0 and negative 1 and negative 2 and negative 3, etc. It's the integers. Every integer can be written as a division of two integers, where the bottom number is not 0. That makes it rational. Every integer is a rational number. But what about every rational number is an integer? Well, this one's false, because 3 over 4 is a rational number. I know it is. 3 is an integer, 4 is an integer, and that bottom number 4 is not 0. Those are the three things you have to check. That's a rational number. But it's not an integer. This is not an integer. But it is a rational number. So I found a rational number that's not an integer. So how can I possibly say each and every rational number is an integer? I found one that isn't. Okay, this completes the section on basic definitions.